Hello there. So today we are going to be doing the fifth lab of learning the art of electronics. It is constructing a differential amplifier. I'm leaning down here on the desk so that you can see my face because I don't have a good enough stand, and I want you to sort of be able to see the circuit as I make it up as well. I'm just gonna sort of record the whole thing of me doing the lab, and then I'm gonna edit it later. So I hope you enjoyed just watching me construct this circuit. I will, of course, put on like we'll be doing some analog discovery 3, so you'll be able to see it on my computer there when I do it. And I will also be constructing the circuit, like a circuit schematic on the computer as well. Okay, thank you. So first up, we have to construct the circuit that is found on um, page 209, which uses 3096 array. As well. So let's just go through that. And this schematic is found on page 209 of Learning the Art of Electronics. However, there is some differences on mine. First of all, I'm using plus 5 volts and minus 5 volts because I'm using the analog discovery 3 to create that. So I sort of modeled that, like I put that into the schematic at this point already. And then basically this is the collector resistor, 10 kilo ohms. Then I'm using two NPN transistors, two N3904s. Instead of what they recommended was to use the 3096 array. But I didn't have it, so I didn't use it. And then these 100 ohm resistors are the emitter resistors, and then the 10K resistor I just have labeled as R1. Yeah, and then I calculated the different gains, as you can see here, based on equations given to me through the textbook. And I got the differential gain as 40 and common mode gain as minus 0.5. Now, I'm going to skip over to where we 5L 0.1.5, where we're going to basically measure the common mode and differential gain. First, I am going to show you the little schematic I have made up for it, just so you can see where everything is connected and what we're actually looking at when I go to show you in the video the analog discovery 3 channels. So we have the plus 5 volts, minus 5 volts, analog discovery 3. Now, this is for the common mode calculation. So we got the wave function generator right there on the analog discovery 3, going to both of them. And then we have channel 1, basically at the input of the one transistor. And then we have channel 2 at the output of the circuit. This circuit here, you see we have the wave function generator, and that basically will be reading on channel 1, so a 1 volt sine wave. And then we have channel 2 over here, and it's shifted up. To me, I thought it was shifted up, but really it's just up there. And it is roughly half of the size. So you see that's like 2 or 1.8 to about 2.8. So at 1 volt So a half volt amplitude sine wave, and we expected the common mode gain to be 1/2. So that aligns with what our expectations were. But anyways, I'm going to point out some things that might be confusing. So, first of all, the wave function generator 2, I connected here. This is where W2 gets connected, right there. The wave function generator 3, to get the proper differential waveform that I wanted, I axed it out. That was out. I believe I do bring it back later to show sort of a little scraggly double thing at this point. Yeah, that's there. I'll just cross that out. Since this isn't common mode we're measuring differential mode. What if I just stop W1? There. Now I think we have it. So I just turned off wave generator 1. Then our output just became much, much different than our input. 10. Let's just continue on. Like, see, it's so small now, we have like big error bars. Look, I think that's going from, they're about at the same amplitude now. This is going down to 1.5 up to 4.5. That's about 2 volts. Now they're even, I would say that this one's still even a bit bigger. We're at 10 millivolts. So that means, so if it's at 10 millivolts, the other one's reading at 1 volt. 1 divided by, that says a gain of 100. Oh, wait. It'd be 283 is applying it on just one of the two. And then W1 is applying on both of them. You can see which signal is getting amplified more. I said the differential is 100, but that seems high for some reason. Maybe we'll think about it some more as we analyze the results. I'll just take a quick screenshot of this. Now, it also asked us to run both at the same time, perhaps at different frequencies, it said. So let's do that. Yeah, now we can see, let's actually make this a little bit bigger. That's pretty wonky looking. Here, let's turn off channel 2, which is the input. Oh wait, I mean the channel 2 is the output. Let's look at channel 2. So yeah, you can see the output of it. It's really, that's pretty wicked. That's the, so this is the common mode. One is the small little blips. And then the big one that we see, that's the differential output. Okay. So now it wants us to replace the 10 kilo ohm resistor with a current source. So I shall see if I have the JFETs that it's talking about. Otherwise, we're going to have to construct another circuit that's on the next page. They do have it this time, though, so that's good. Let's just turn all these off. So first, I just want to construct this current sync. I think we might have to make some changes to the one they've described over there. But I might as well try theirs out first.